Hello and welcome to this course on Data Science for Business Analytics and Intelligence. I'm Pragyan, a data scientist at the ClickReader, and I'll be instructor for this course. In this course, we'll be going over the Google Merchandise Store's customer dataset, which contains about 1 million data points collected using Google Analytics. We will be learning how to clean, analyze, and model such datasets using machine learning in order to predict the revenue generated per customer. And although our choice of dataset for this course is Google's own internal dataset, you can apply the knowledge that you gain through this course for your own business and for predicting which of your customers generate what amount of revenue. Please be mindful that in order to effectively grasp all the concepts taught in this course, you should at least have a basic understanding of Python as well as machine learning. So, if you're ready and if you're excited to learn all of this through a very hands-on approach, let us hop into the course and start learning. See you there. Hello and welcome to this lesson on Overview of the Learning Methodology. Before we start working on the dataset, let us understand about the learning methodology that we will be following. This course consists of multiple hands-on lessons that you will be actively going through in order to gain valuable knowledge for your business. A lot of things will be done by me, but you will have your own fair share of exercises to hone your data science skills. At the end of the day, the objective here is to help you gain the skills that are needed to transform your business into a data-driven entity. The dataset that we will be working on comes directly from the Google Analytics Customer Revenue Prediction competition on Kaggle. As the competition name suggests, we will be trying to predict the revenue generated per customer based on their online presence. For this, we will be using Google Merchandise Store's web session history data as well as the internal transactional data. We will follow a 6-stage data science workflow for successfully completing this course. We'll start by understanding, optimizing and cleaning our dataset. We'll then move on to analyzing the data as well as pre-processing it by performing data splitting as well as other pre-processing techniques. We'll then build our model, train it and evaluate it. So, if you're ready to learn, let us start this course by understanding more about the dataset using Python. Also, I will be using the Jupyter Notebook as my IDE for this course, but you can use any other IDE that you are familiar with. So let's start coding. Hello and welcome to this lesson on Understanding and Optimizing Customer Datasets. In this lesson, we'll be focusing on the Google Merchandise Store's customer dataset. This dataset contains information about the session history of each user on the GStore's website along with the generated revenue in case they ever made a purchase. So, our goal with this lesson is to learn what kind of data we should be collecting for our own business in order to properly apply business analytics and intelligence. And since most of the data fields present in this dataset is based off of Google Analytics along with some internal transactional data, any business can apply the techniques taught in this course to harvest and optimize such datasets. So, the dataset contains the following information and we have the data dictionary over here. So you can pause this lesson and have a good look at all of the different columns and what they mean in this data dictionary. But for now, let's move ahead. So let us start this lesson by importing the necessary libraries. And for this lesson, we'll only need the pandas library. So we're importing pandas as PD to work with data frames. I'll run this line of code and make the import happen. Next, let's import the CSV file called gstore_data.csv, which contains information about each user's website visit along with the revenue they generated for Google. So for this, I'm calling the read_csv method off of the pandas library and I'm specifying the file path as data/gstore_data.csv since our CSV file is within the data folder. And I'm also specifying the parameter low memory as false since some of the columns in this dataset have mixed data types. So once this CSV file has been read in as a data frame, we're storing it in the variable store_df. So I'll run this line of code and make this assignment happen. Great. Now that the data frame has been read in, let us look at the first 5 rows by calling the head method off of the data frame. So I'll run this and we have our data set over here. So here we have the first 5 rows and we have a bunch of columns. So pandas is limiting the number of columns that we can see right now. So let us look at the entire shape of the data frame. So for this, we can call the shape property off of the data frame. So if I run this, we can see that there are about 900,000 different user sessions recorded on the GStores website in this dataset, and there are 55 different columns which are given by the column headings over here. So since this dataset is large, let us see how much memory it occupies, since the theme of this whole entire lesson is to optimize this dataset. And we'll also be learning how you can optimize your own datasets by following along with this lesson. So to look at the memory uses, I'm calling the info method off of the data frame and I'm specifying the parameter memory uses as deep. So if I run this, we have the entire column names over here along with the non-null count, which is the values which are not null, and the data type. So you can see that most of the columns over here are of an object data type and some have specific data types such as int64, boolean, float64, and that's it. So if we look at the memory users over here, we can see that this data frame is currently occupying 2.6 gigabytes of memory, which is quite large. So now the question becomes, should we remove the rows or should we remove the columns in order to reduce this memory usage? So let us talk about both of them. So first, should we remove the rows, that is the session history, in order to reduce memory usage? So we should keep in mind that session history is very important for profiling the customers of a business along with the behavioral patterns. Therefore, even if the dataset feels large, we should not remove the rows in the dataset as long as possible. Alternatively, we can take a sample out of the dataset that is most representative of the entire dataset in order to conduct our analysis. This is what most statisticians do. But since we will be performing machine learning later on in this course, let us keep all the rows of data for our analysis, since machine learning algorithms need a large number of data points. Now, should we remove the column, which is the data fields, in order to reduce memory usage? So the removal of a column is completely dependent on the data it holds. If a column doesn't contain data that is significant to analysis or modeling, then it can be removed. Examples of such columns are columns containing mostly null values, a single constant value, or a randomly generated value. So first, let us print out all of the column names in the dataset to look at the columns. So here we have channel grouping as the first column in the data frame and traffic source.campaign code as our last column in the data frame. Now we can select any of the column and print out the unique values in it by using the AndUnique method. So here I'm selecting the channel grouping column from our data frame and I'm calling the AndUnique method by specifying the parameter drop NA equals to false, which means that we want to keep the null values in this column. So if I run this, we get the output as 8. So there are 8 different unique values in this column, which is channel grouping. So we can also print out the unique values for all the columns at once, and for this we can just call the AndUnique method off of the data frame itself. So if I run this, we can see that we have the column names and the number of unique values they hold on the right side. We can see that there are a lot of columns containing only a single value. So let us phase them out programmatically by appending them into an empty list. So I am creating an empty list over here which is called single_val_calls. Then I am looping across all of the column names by writing for x in store_df.columns. So each time this loop runs, the column name will be assigned in the variable x. Then I'm checking if store_dfx, which is the selected column's number of unique elements, which is given by the AndUnique method, is equals to 1 or not. So if it equals 1, then we are appending the column name to our empty list over here. So I'll run this and let's wait a while. Okay, now if we look at the variable which is single_val_calls, we have a list of all of the column names containing only a single unique element. So these columns may contain some kind of data value. However, the information in them is non-existent since they do not help to distinguish one user's session history from the other. So let us remove them using the drop method off of the data frame. So I'm calling the drop method from the data frame and I'm specifying the list of columns to drop as our variable which is single_val_calls, and I'm specifying the access as 1 since we are trying to drop the columns. Then I'm specifying the parameter in place equals to true since I want to reflect this change in our original data frame which is store_df. So I'll run this, and if we look at the first 5 rows again, we can see that there are 36 columns now. Also, if we look over here, we have some ID columns. So even if full visitor ID and visit ID have been generated for this session history, they are actually being assigned to the user itself. But the session ID over here is randomly generated, and this means that we can drop it as well since this does not provide any information to us. So for that, I'm calling the drop method again and I'm passing in the column name as session ID, the access as 1 since we're dropping the column, and we're putting in place as true. So I'll run this and we have dropped the session ID. So let us check again if we left out any column that doesn't add value to us. So I'm calling the AndUnique method for finding the unique elements in the data frame which is store_df. So I'll run this, and as you can see, now we have a reduced number of columns with all of the unique data values being more than 1. So looks like all of the columns are useful. Now finally, let us check the memory uses again. So I'm calling the info method off of the data frame and I'm specifying the memory uses as deep. So I'll run this and we can see the memory uses is 1.2 GB, and that's a huge improvement since we started at 2.6 gigabytes. So looking at the data fields, we can also see that the data set can be grouped into various categories such as session visit information, which is given by these data fields over here. Also, we have the device information given by these data fields. We have geographical information given by GeoNetwork data fields. We have the aggregated information given by totals data field, and we have the traffic source information given by the traffic source data fields. So these will be our features for predicting the revenue information, which is given by the column name totals.transactional revenue, which is over here. So finally, let us export this optimized data frame to a new CSV file so that we can use it in further lessons. For that, I'm calling the to_CSV method off of our data frame and I'm specifying the file path as data/ and the file name which is optimized_gstore_data.csv, and I'm specifying the header which is the column names to be present in this dataset but the index to be dropped. So that is it for this lesson, and I'll run this line of code to make the export happen. So as an exercise, I would like to encourage you to look at the content of each column by selecting them from the optimized data frame one by one. Next, create a note of how valuable the columns may be in order to predict the revenue generated per customer. This will help you to further understand the dataset and prepare yourself for the upcoming lessons. By the way, if you're looking at this lesson on YouTube, this was an introductory lesson of the course Data Science for Business Analytics and Intelligence. If you want to keep on learning even further, you can click the link in the description and enroll in the full course. If you do so, you'll get a lifetime access to the entire course materials as well as a certificate of completion when you complete the entire course. So this is it for now. Bye bye.